We've been talking about function operations and compositions, and we've been doing them algebraically. And now I'd like to finish the section by going back and looking at operations and compositions from a graph and also from a table. So in this next example, we'll use the graphs to evaluate each expression. You can see in part A we have f minus g of 1. We need to apply the definition of the operation. We need to write this as f of 1 minus g of 1. And then we can evaluate f of 1 on the graph. Make sure you're on the correct graph. This is the f graph. This says the input is going to be 1. What is the corresponding output? It's 4. F of 1 is 4. G of 1, again, make sure you're on the right graph. The g function is over here on the right. When x is 1, y is negative 1. So 4 minus negative 1 gives you an answer of 5. You might want to go ahead and try to do the rest of these on your own. In part B, we have f times g of 3. So that's f of 3 times g of 3. And so if we look at the f function, we see that when the input is 3, the output is 4. When we look at the g function, when the input is 3, the output is 5. 4 times 5 is equal to 20. Let's try a composition. G circle f of 3 is the same as g of f of 3. And so we need to start by figuring out what is f of 3. In this case, make sure you're on the f function. When the input is 3, the output is 4. So we want g of 4. Over on the graph for g, we see that when the input is 4, the output is 8. Let's do it again. This time let's do f circle g of 2. Apply the definition, f of g of 2. What is g of 2? G of 2 is 2. So what is f of 2? F of 2 is the vertex of the parabola. The output is 1. So that's our answer. Okay, those are nice problems. Let's go on and let's do something very similar. This time let's look at tables to get our values, to get our function values. So here in part A, we have g minus f of 4. So that would be g of 4 minus f of 4. Again, be very careful that you're looking at the right table, just like you needed to make sure you were looking at the right graph up above. G of 4 is over here in the second table. When the input is 4, the output is 0. F of 4 in the table on the left, when the input is 4, the output is 2. So we have 0 minus 2, which is negative 2. Let's try another one. G circle f of negative 2 is g of f of negative 2. F of negative 2 is in the first row of the first table. F of negative 2 is 1. So G of 1 is in the first row of the next table. G of 1 is 2. One more problem. F circle G of 3 is F of G of 3. The inside function is G. G of 3 is negative 2. When we put that negative 2 into the F function, what comes back is 1 right here. Okay, that's all for section 2.8.